Hello everyone, my name is Nithin. I'll be explaining our COA assignment factorial of a number stored in memory location 60H and stores the result in 61H. Start org 000H. This tells the assembler that the program starts from memory address 00H. Move A comma 60H. Move R0 comma A. The number whose factorial you want to find is stored at the address 60H. It is moved into register R0 for use in the loop. For example, if 60H has a 05H, that's 5, then R0 is equals to 5. Move R0. Okay. ಕಟ್ ಮಾಡ್ಕೊಳ್ಳ ಇದನ್ನ ಆಮೇಲೆ move A comma R0 JZ fact 0. If the number is 0, jump to the fact 0. Because factorial of 0 is defined as 1, move A comma 0H 01H, move A 61H comma A. R1 will hold the running product, the result. Initially R1 is equals to 1 since factorial starts from multiplying from 1. Factorial loop. Now entering the loop, move A comma R1, move B comma R0, multiply AB, move R1 comma A, decrement R0, factorial loop. Let's break this down now. Move R1, move R1 into A, move R0 current number into B. Mul AB means multiply A into B, the result A lower byte and B upper byte. The result A is stored back into R1. Decrement R0 by 1 and jump back if it's not 0. This repeats a multiplication for all numbers down to 1. Moving on to the execution. So here I am taking for the 60H I will be entering the number 5. When I run it, it gives the answer 78. This 78 is an hexadecimal value. Converted into decimal value, it is the 120. This program finds the GCD. So the second program is finding the GCD of two numbers stored in the memory location 62H and 63H, and then stores the result, the GCD in 64H. org 00H LJMP start. The microcontroller starts executing the memory at address 00H. We use LJMP start to jump to the actual program that begins at the label start. Move 62H 30H, move 63H 12H. 30H and 12H is nothing but 48 and 18 in decimal. Number 1 is equals to 48. It is stored in the memory location 62H. Number 2 is 18 and it is stored in the memory location 63H. These two are the inputs whose GCD we want to find. Call GCD sub SJMP. The program calls the separate block of code named GCD subroutine that actually does the calculation. After it is done, it jumps to the $sign, meaning stay here forever. This is where the actual GCD logic happens. Move A comma 62H, move R0 comma A, move A comma 63H, move R1 comma A. Move the first number from 62H into the register R0. Move the second number from 63H into the register R1. So then R0 will be 48. R0 will having the 48. And R1 contains the 18. G loop. Move A comma R0. Clear C. Subtract A comma R1. Move R0 into A accumulator. Clear carry. C is equal to 0. So the subtraction works properly. Subtract R1 from A. A is equal to R0 minus R1. JZ G equal JC R0 less. If neither is true, it means R0 is greater than R1. Move R0 comma A, SJMP G loop. Replace R0 with the result R0 is equals to R1 minus R0 minus R1, jump back to the start of the loop to continue. R0 less, move A comma R1, clears C, clear carry, subtract A from A comma R0, move R1 comma A, SJMP G loop. If R0 was smaller, subtract R0 from R1 instead. Store the result back in R1. Go back to the loop and repeat. G equal move 64H comma A RET. When both become equal, the value A is the GCD. Store it in the memory location 64H. RET returns to the main program, which then halts. So the execution goes. So here in the 62H is the value 30H, and in 62H, 63H, it contains the 12H. Here is the output. This third program calculates the sum of squares of n natural numbers, where n is stored in the memory location of 67H. ORG 00H LJMP start. It means when the microcontroller starts running, jump to the start label. That's where our main program begins. ORG 0030H start. The actual program starts at the memory address 0030H. Move A, 67H, move R5, A. Load the number stored at memory 67H into the accumulator A. Copy that into register 5. This will be our loop counter. How many times to run? Move R3 01H, clears 68H, clears 69H, JZ done. R3 is equals to 1. This will be our current number whose square we are calculating. 68H and 69H is equals to 0. These are used to store the sum of squares like 16-bit total. JZ done. If the input number n is 0, null, skip everything and go to the end, since 1 square plus null plus 0 square is equals to 0. Loop. Move A, R3, move B, R3, multiply AB. This part calculates the square of the current number R3. Move A, R3, this moves the number into A. Move B, R3, moves the same number into B. Multiply AB, multiplies AB. Result goes into a low byte and B high byte. Move R4, A. R4 temporarily stores the low byte of the product. Move add A, R4. Add the low byte to the 68H, the low byte of the total. If there is a carry, it adds it into the high byte 69H along with the high byte of the product B. So after each loop, the sum of the squares keep increasing correctly. INC R3, DJNZ R5 loop. INC R3, go to the next number, that is increment I is equals to I plus 1. DJNZ R5 loop, decrease R5 by 1, and if it's not 0 yet, go back to the loop. This repeats until we have added all the squares up. Done. SJMP means stay here forever. The program is done until the program is done. So moving on to the debugging part. I'll give the number 5 to the 67H of the memory address. Next, when I run, it calculates the sum of the squares of the 5H. It gives the 37H hexadecimal value. Moving on to the last program finds the square of a number stored in the memory location 65H. It calculates n into n using the repeated addition. ORG 00H LJMP start. The program begins at memory address 00H. It jumps to the label start where the main program begins. Move A, 65H. Move R2, A. The number you want to square n is stored at the memory location 65H. It's loaded into the accumulator A and then copied into the register R2 for use in the loop. Move R3, 00H. Move R4, 00H. R3 and R4 will hold the 16-bit result of the multiplication. Initially, both are set to 0. Move A, R2, move R5, A. JZ store result. Copies the number n into R5, which acts as the loop counter. If n is equal to 0, the program skips to the loop since 0 into 0 is equals to 0. Move A, R3 loads the current total low byte into accumulator A. Add A, R2 adds in to it. A is equals to A plus N. Move R3, A. Store the new low byte result back into the R3. Now we'll handle any carry. In case of low byte in case the low byte overflows, move A, R4, load the high byte. Add CA 00H, add carry if any. From the previous addition, move R4, A, store it back into the high byte. DJNZ R5, loop, add, decrease the R5 loop counter. If R5 is not 0 yet, go back to the loop add and repeat. Store result, move 66H, R3, move 67H, R4, SJMP $. Once the loop is done, the result, which could be up to 16 bits long, is stored. Continuing the debugging. In the 65H memory address, I am giving the number 5. When I run, the value is stored is as 19H, which is the hexadecimal value of 25. Thank you.